Hello pre-calculus students and seekers of truth. In this video we are going to talk about polar functions and polar graphs. So let's get right to it. Alright, so a polar function, and let me define it as follows. Right? It is a function whose input is theta. In other words, input is an angle, which we will call theta, and output is the radius, and it's a directed radius. So the radius could be positive or negative r. So if we think about our function machine, it'll look something like this. You're going to input an angle or theta, and we are going to get the output r. All right. And again, this is theta is an angle that we rotate, and then we are going to get a radius, which is which direction do we go in, left or right. Okay, and a polar graph, right? So we are going to graph polar points r theta, except instead of graphing them the traditional way, we're going to graph them on an xy plane. Okay, so these types of graphs are going to look a little bit unfamiliar. And so let's look at one quick example. Let's say I have a polar function r of theta is equal to sine of theta, right? And we are going to start out with a table. Input is theta, value is r. The polar coordinate point is going to be r comma theta, and then we'll create our graph right here. Okay, so let's say that theta is equal to 0. That means if we plug 0 in here for sine, we will also get 0, and our polar coordinate is 0, 0. So when we plot this, it's just going to be the dot at the origin or the pole. Let's say that we plug in another number. Let's say that theta is pi over 4. Then r is going to be sine of pi over 4, which is root 2 over 2. And our polar coordinates is going to be root 2 over 2 pi over 4. Okay, and now here is where this graph gets really interesting. Root 2 over 2 is approximately 0.7. So let's say we have a polar graph here, and we make our graph paper using a bunch of concentric circles. Okay, so that's 1, that's 2. So root 2 over 2 is like 0.7, and we're going to rotate it pi over 4 radian. So that's going to be that dot there. All right, and let's do a few more of these. Let's say we have pi over 2. If we plug pi over 2 in here for theta, we're going to get 1. So our coordinates here is r is 1 and theta is pi over 2. So we're going to go out to 1, and then we're going to rotate pi over 2 units, and we're going to get to that point. Okay, and then if we plug in lots and lots of points, we'll be able to get a more complete picture of what our polar graph looks like. So here's just 3 basic examples. Now the thing that makes this a little bit tricky here is that we're graphing this on the xy plane still. This is still the xy plane, but using a different system. Rather than going right and left, up and down, we're going to go right and left and then rotate some amount. Okay, so one of the things that apply that we have to be careful with here is that the vertical line test does not apply here. You could have a function in polar mode that is a function that meets all the criteria of a function, but the vertical line test is failed. All right, and I just wanted to show you what this graph looks like. So in our online Desmos graphing tool, if we were to graph r equals sine theta, all right, r equals sine theta right here, type this in right here in Desmos, we get this graph. So it's actually just going to turn out to be a circle. But you can see some of the points here, and again, these are polar points. 0, 0 is here. So when r is 0, theta is 0. If we have, this is, if we go all the way out to here, this would be like 0.7 pi over 4. That would be this point. And up here you can see that this is 1 pi over 2. Okay, so I hope this clarifies a little bit as to where these points are coming from. When you just look at like 3 dots right here, it doesn't quite make a whole lot of sense, but maybe if we graph all of the points here, you know, we can see a little bit of how a polar graph is generated. All right, so we'll end this video here. Make sure you watch the next couple ones where we get into some of the more nitty-gritty details of a polar function.